we just looked at the roller coaster scenario, but the same theory applies to pretty much anything that is traveling around a vertical circular loop. So this one we're looking at a jet fighter pilot who's making a stunt maneuver where he makes a loop-to-loop. I was looking up, and there's apparently different types of loop-to-loops. Sometimes the pilot's upright at the top of the loop. But we're just going to look at the scenario like what we saw in the roller coaster one. We're going to say that the plane is going to be upside down when it's at the top of the loop. So it's going to go around, and it's up here. We're going to say the plane is upside down. Now, if you understand the roller coaster one, this question is no different. So what we're going to do is we're going to draw our forces on this one. So when they're at the bottom, we know force of gravity is down. Normal force must be up. When we're at the top, if they're upside down, normal force is down. And force of gravity is also down. So we can solve for whichever one we want first. Okay, so let's solve for the top first. Why not? So we have at the top, we see our centripetal force. What's causing our centripetal force? Both the normal force and the force of gravity. Again, this is exactly the same as the roller coaster question. We're just now putting numbers to it. We're solving for normal force. We see normal force is equal to Fc minus the force of gravity. So we get mv squared over r minus mg. And we plug in our values. This is 85 kilograms. We're traveling at 550 meters per second. Our radius is 4,400 meters. Pretty big. And it comes out to a value of 5.0 times 10 to the 3 newtons. And if we're looking at the bottom of the loop, we have our centripetal force is equal to our normal force minus our force of gravity, again, because think of the towards the center is positive. Normal force is equal to centripetal force plus our force of gravity. So we get mv squared over r plus mg, and that comes out to be 6.7 times 10 to the 3 newtons.